Now let's look at example 3. A rope of length 2/5 meters is cut into 4 equal parts. What is the length of each cord? Now to solve this, again, I'm going to set up a division problem. I'm going to change it into it and solve it with a multiplication problem. And then I'm going to prove it with a model. But actually, I'm going to prove it with two models that are very similar to one another. And you might like these models better than the area models. It's called a bar model or tape diagram. A little different than the tape diagram that we talked about earlier. And we're also going to do it with a number line. So let's first set up the division problem. Remember, the first number in division statement is the dividend, which represents the total. We're going to cut it equally. That means we're going to be dividing into the divisor, which is how many groups, how many pieces. And then we're going to get our quotient, which is going to tell us how much or how big. In this case, the length is how big is each piece of those cords. I start out with 2/5 of a meter. I'm going to split that into 4 equal pieces. We're going to find out how many or how big is each piece. How much or how big is each piece. Let's change it into a multiplication statement in order to solve. Keep it, change it, and flip it. I get the 1/4 because I can think of 4 as a fraction as 4 over 1. So flip that 4 over 1. Now, can I reduce diagonally? Yeah, I can look at the 2 and 4 and say I can divide a 2 out of those. So if I divide 2 by 2, I get 1. And if I divide 4 by 2, I get 2. I can't reduce the 5 or the 1, so now I multiply straight across. 1 times 1 is 1, and 5 times 2 is 10. So how big is each cord? Each cord is 1/10 of a meter. Now let's prove that using a couple different tools here. Okay, starting with a bar model. All right, a bar model, sometimes they call it a tape diagram. It's a little different than what we used in Module 1. I'm going to always first draw my total. Well, my total was 2/5. If I let that whole bar represent one whole, I'm going to split it into 5 equal pieces. Imagine those are 5 equal pieces. I get 2/5 by coloring in 2 of those 5 equal pieces. I'm going to label that as 2/5. Now, if I've got to split that into 4 equal pieces, I've got to split the green, everything that I've got colored in green, into 4 equal pieces. I've already got it split into 2 equal pieces. In order to get 4 equal pieces, I just go like that. And I'm also going to split these over here so that we all have the same size pieces. Finally, how big is each of those pieces? How big is this? This is 1 out of, and if we count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 1/10. Once again, it proves our answer of 1/10. Another tool that we can use very similar to the bar diagram or the tape diagram model is a number line. What I'm going to do is I'm going to draw a number line. And I'm going to first mark out where my total would be. So this is 0, and this is 1 whole. If I'm splitting that area up in order to find 2/5, I'm going to split it into 5 equal pieces. So that this is 1/5, this is 2/5, 3/5, 4/5, and of course 5/5 is 1 whole. I start out with 2/5, so I go from the 0 to the 2/5. That's what I start out with. I want to split that distance up into 4 equal pieces. Like the bar model, I see that I already have it divided into 2 equal pieces, so I just go like that in order to split it into 4 equal pieces. I'm going to split the rest of them to make it equal sizes, and then I want to ask myself, how big is each of those pieces? How big is that piece right there? It's 1 out of 10 equal pieces. 1/10 again.